Welcome back, everybody, and thank you again for taking your time to come back for part 2 of this data modeling with Amazon DynamoDB series. My name is Rick Houlihan. I'm a senior practice manager for NoSQL at AWS. Many of you know me from my other sessions here at reInvent and other content that I've delivered. Again, we have Alex Debris here to present the part 2 of this session. Alex is the author of the DynamoDB book and an engineer at Steady. Thanks again, Alex, for taking the time for today's session.
Thanks, Rick, and welcome to Data Modeling with Amazon DynamoDB. I'm Alex. I'll be your guide here as we learn how to design a nice, clean, efficient DynamoDB data model. This is part 2 of a 2-part talk, so just a quick recap of what we covered in part 1. We did a little bit of foundational vocabulary terminology stuff, just the DynamoDB basics to get you on your feet. And then we talked about SQL versus NoSQL, and this helps you understand a little bit of the underpinnings of DynamoDB, of NoSQL, what it's trying to do, and how you need to adjust your data modeling accordingly. Finally, we looked at some one-to-many relationships, some strategies there to handle one-to-many relationships in DynamoDB. In this part 2, we're going to dive even deeper on some of this stuff. So we're going to start off with the data modeling process. What does it look like to model your data in DynamoDB, and how does that differ from a relational world? And then we're going to go into 2 different sections about strategies. So we have filtering strategies and sorting strategies. So I think this is really interesting if you want to learn how to model in DynamoDB. Once again, who am I? I'm Alex Debris. I'm the author of the DynamoDB book, which is just a comprehensive guide to data modeling with DynamoDB. Check it out. It's got 450 pages. It's got strategies. It's got concepts, and it's got a full walkthrough example. So make sure you check that one out. I'm also the creator of DynamoDBguide.com, which is a free resource out there if you want to learn how to use the DynamoDB API, learn some of the concepts behind DynamoDB. Check that one out. I'm an AWS data hero due to my work with DynamoDB, and then in my day job, I'm an engineer at Steady. So if you want to come work with me, go check out Steady. So let's get started. I want to start off with the data modeling process and understand how you should just sort of think about your problem in DynamoDB. And it's going to be a little bit different from what you do in a relational database. So I think of this in about 5 different steps. And the first one is really before you even start doing anything, you need to understand your application. This is going to be true in a relational database or a non-relational database, but especially in DynamoDB, make sure you understand your application and what you're doing. What are the different objects you have in your application? How are you going to be accessing them? Make sure you really grok that. So if you need to sit down, with a product manager, or a business analyst, or a tech lead or whatever, make sure you know what your application is doing. Once you've done that, then you should create what's called an entity relationship diagram, or an ERD. And what this is going to do is just map out the different objects in your applications and how they relate to each other. So in part 1 of this, I talked about a SaaS application that had 2 entities. This would be the ERD for that application, right? We had organizations. We also have users. So those 2 different entities represented as boxes. And then there's a line between them indicating a relationship. And this shows that, organization has multiple users. So you're representing the objects and the concepts, the relationships between the entities in your application. This is a very simple one. You might have a more complex one. So this one's from my book where we model the whole GitHub backend. And you can see we have a lot of different entities in there. We have users, we have organizations, we have repos, we have issues, pull requests, comments, stars, reactions, all that stuff. It gets very complicated very quickly, but make sure you have modeled all this out and thought this through. This is going to help you organize your data model before you start actually modeling in DynamoDB. So if you're working with a relational database, you can also create an ERD, and usually you take that ERD and you just ship it to your database, right? Each box in your ERD becomes a table. You map those relationships using foreign keys or maybe a joining table, and then you're done. Then you think about writing your queries. With Dynamo, that's not quite the case. Dynamo, the next thing you need to do is list out your access patterns. You need to think about the actual patterns you're going to use, because that's how you're going to model your table to handle these access patterns. And I don't mean list your access patterns in a generic way and think, oh, I have users, oh, I have organizations, I'm going to need to get them and delete them, things like that. But actually write them down, right? You might have something like this. This is an example from the book where I had a messages entity, right? And think about all the different access patterns you have around messages. You have view messages for user. You have view unread messages for users. That's an actual different access pattern you might need to handle differently. You have a send new deal message to all users. You have a send new brand deal message to just the brand watchers, right? You need to get specific with these access patterns, list these all out so that you know how to handle them in your DynamoDB table. So once you've listed your access patterns and listed all those out, then you need to design your table specifically to handle those access patterns. And you just work through your access patterns and think, how do I handle this? What's the primary key I need to use here? Do I need to add a secondary index here to handle this? And the nice thing is, this is all before you write a single line of code. You can do this, with pen and pencil. You can do this on your computer. But if you take that list of access patterns, you should end up with an artifact like this, an access pattern chart that it lists your access patterns down the left side, and then it says, hey, what index am I using? Am I using my main table? Am I using a secondary index? What parameters are going to be involved? Do I have any other notes on how this is going to happen? And you should have all these details about your access patterns. Another artifact you might have as a result of this is what I call an entity chart, right? If you go look at your ERD and the different entities you have, just make them out into a chart, list them down here. Remember, if you're using that single table design, you're going to put them all in the same table. So you need to think, what's my PK? What's my SK going to be for those? What are the templates I'm going to have? Here's the beginning of the GitHub entity chart. At the end of the process, you're going to have an artifact like this that you can put into your repo, link in your docs, however that works. But it's going to say, hey, for each entity in my application, here's the PK, here's the SK, here are my GSI SKs. Right? If I have secondary indexes, there are the primary keys for those. All that stuff. And that's really going to help you as you get into that data modeling. Now it's very easy just to go from those charts to go into code and implement it. Finally, last thing about the data modeling process is you need to know your strategies, right? And strategies, we looked at those in the last section about one-to-many relationships, the different strategies there. With Dynamo, you're going to have these different strategies to accomplish your goals, and you really need to know not just your situation, but different strategies to handle those situations. So that's what we're going to do in the next two sections of this talk. We're going to start off with filtering strategies, and I love doing filtering strategies because I think filtering is the most important part of a database, right? No matter what database you choose, you need to figure out efficient ways to narrow down this giant mess of data into the actual pieces you want. Because at different times you want that piece, but not this piece, or this piece, but not that piece. How do you do that? If you come from a relational world, you might be used to having this magical where clause that does a lot of the work for you, right? So when you're working with a relational database, you can use where, and you can filter on column values. You can join in a table, filter on those column values. You can use built-in functions like the current time, things like that. DynamoDB does not have that same flexibility with that where clause. You need to be more intentional about how you're modeling your data. That's what we're going to talk about in this filtering strategies section. Remember, the primary key is going to do most of your work. We talked about this in the last session where you need to query with those primary keys. So the key point is almost all that filtering is going to happen with your primary key, and that's going to be an important part of your data model design in DynamoDB. So given that, let's talk about the 4 different strategies for filtering that I want to talk about here. First one is going to be filtering with the partition key. We've already seen a little bit about this, but the partition key is very important in DynamoDB. Remember, we talked about this chart in the first session where DynamoDB is splitting your data across all these different storage nodes, called partitions, and each one of them is going to hold maybe 10 gigs of your table data, right? So they've segmented them into these different partitions, and importantly, when you make that request to DynamoDB, the first thing they're going to do is figure out which partition that item belongs to based on the partition key coming in. And the great part about that is that's a constant time operation. No matter how big your table gets, this is going to be constant time. It's going to be very efficient to narrow down from 10 terabytes down to 10 gigabytes. So you want to use that partition key to filter your data. If we go back to the example we had in that first session, we had actors and actresses and movie roles that they'd been in. That's what we have here. So in this one, it's very easy for us to use that partition key to filter down our data, right? We can use what's called the query operation, which requires you to give in an exact match on that partition key. And it's going to filter down to that partition, to that item collection, and get you all the items there. So it's very easy for me to say, hey, give me all of Tom Hanks's movies. I'm going to get Castaway. I'm going to get Toy Story back. So partition key, very important in your data modeling. You're going to use that to break up your data into a lot smaller chunks there, so then you can operate on it. So in this example, we use the actor, but in an e-commerce example, it might be broken down into customers, right? You might have customer partition or user partition somewhere else. Use that partition to really spread out your data so that you can get nice distribution of your data. So partition key going to be very important. Sometimes you have additional filtering patterns. That's where the sort key comes in. You can add additional conditions on that sort key to filter down even more. So let's talk about the sort key a little bit. One thing to know, first of all, is that the sort key is sorted. That's why it's called the sort key. It's going to be sorted. We're going to talk about that a little bit more in the sorting strategies next. But just know that that sort key is sorted within a particular partition key. There are 2 patterns to filtering with the sort key. And the first one is when the sort key itself has meaning. Maybe based on what that sort key is, you know exactly what you want to find. So the example I'll show here is, imagine you have an IoT application where the partition key is going to be the sensor ID, the sort key is going to be the timestamp. You can see that the sort key itself here has meaning. It's sorted in order based on that timestamp, but I know what that means, right? I can filter for all the items between 2 timestamps. I can go get a specific timestamp if I want to. That sort key itself has meaning in this particular situation. But very often, the sort key might only have meaning based on how you've modeled it. And you really need to know your data model for that to work well. So let's look at an example of what I mean here. This is a more complex example. This is from the GitHub chapter in my book where we're modeling repos and lots of different things. One thing I want to show you is, look, we have 6 different items on this table right here, and they're all in the same item collection, right? They're all using the same primary key. But we have a lot of different types of items here. Let's look at what we have. First, we have a repo item, right? So that refers to a GitHub repo in our table. We also have some issues, right? When you go to a repo in GitHub, you can create an issue. There's a one-to-many relationships between repos and issues, right? One repo has many issues, and our issue is going to belong to one repo. We've co-located those here in the same item collection. Additionally, we've also co-located these star items, right? A user can come to my GitHub repo. They can star that repo to indicate that they've liked it. There's a one-to-many relationship between that repo and that star relationship. So now what you can do in that sort key is you can make different sort of queries based on the filtering conditions in your sort key to get different collections of items. So first, imagine you have an access pattern that says, hey, give me all the issues for a particular repo. You also want to scoop up that repo like we talked about in the last session in that same request. So what you can do is you can have the query where you make you say it's this partition key, and you have a condition on that sort key that says, hey, go from issues down to repos. That's going to get you all your issues. It's also going to get you that repo item. Filter out those star items that you don't need. Likewise, you can also handle a different access pattern that says, hey, give me all the stargazers for this repo, right? I want to get that repo item and all the people that like it, right? You can do that here by making a condition on that sort key that says, hey, start at repo, go down to stars, and get me everything in between. Now I've got the repos and stars, but I don't have the issue. So I'm able to filter with that sort key condition to get exactly down to what I want to get there. So those are the 2 patterns with the sort key. Again, filtering with the partition key and sort key, that's going to get you most of the way there on 80-90% of your use cases. You might need some additional filtering strategies, and that's what we're also going to talk about here. Next one I want to talk about is what's called a sparse index, and I love this one. This is a pretty fun one to use, and it is pretty interesting. So let's talk about a sparse index. We talked about secondary indexes in the last session, but just a reminder of what that is. You can create a secondary index on your table, and it basically gives you a new primary key. So you declare a primary key for the secondary index, and all the items in your base table are going to get copied into that secondary index if they have those primary key values. So the important thing to know there is that only items that have all elements of a secondary index primary key are going to get copied over there, right? If it doesn't have those elements, it's not going to get copied over. Now, you can use that strategically to help filter out items you don't want based on a particular condition. We're going to see 2 strategies of how this works. The first strategy is when you're filtering within a single item entity type based on a condition. So let's see an example here. Let's go back to our example. This is the SaaS application that we had before that has organization and has users. We've got 2 organizations, Berkshire Hathaway and Facebook, and then a couple users within those organizations. Imagine we have an access pattern that says, hey, give me all the admin users for a particular organization. So I just want to get the admins. Maybe they need special permissions for something, but I don't want to filter out, or I don't want to get all the members, different things like that. So how can I handle that access pattern? What we're going to do is we're going to do this with a global secondary index. So we'll declare this secondary index using these generic primary key values. If you look there, I've added these attributes with GSI1 PK, GSI1 SK. And just like I have those generic primary key values of PK and SK in my primary key, I can do the same thing in my secondary index as well. So GSI, that stands for Global Secondary Index 1, and then PK and SK as well. So I've added these on here. If you look, I have 2 users that are administrative users, and you can see I've decorated those with GSI1 PK and GSI1 SK attributes. So because they're administrators, I'm going to give them these values to go into that secondary index. However, if you look at this 3rd user here, Charlie Munger, he's just a member. He's not an administrator, so we're not going to decorate him with those attributes. He won't be included in that secondary index. One last thing I want to call out here, if you look at the organization items, they also have GSI1 PK, GSI1 SK values. They're being used for a different access pattern altogether, but the important thing to note is you can use this sparse index strategy as a way to overload your secondary index. So if this applies to one access pattern with one entity type, you can have a different entity type with a different access pattern in that secondary index. It's not going to affect anything. Let's take a look at what our secondary index looks like. This is what it looks like here. You can see if we go to that Berkshire Hathaway item collection with that partition key, we only see Warren Buffett. We don't see Charlie Munger. He's been filtered out because he's not an administrative user. So we use that sparse index to filter out members there. So again, that strategy, filtering within an entity type based on a condition. We filter within users based on a condition. Are they administrators or not? And we only gave administrators those GSI1, PK, and SK values. The second strategy you might want to use with a sparse index is when you want to project a single type of entity into a secondary index. And let's see a use case of where that might be useful. Here's an example I have here. Imagine this is an e-commerce store and I have 6 items in my DynamoDB table. The first 2 are customer items. So I have myself and Barry Bonds. We're customers of this particular e-commerce store. Then we have a couple orders, one for each of Barry and me. And we also have some inventory in our store as well. And now imagine our marketing department comes to us and says, hey, you know what? Every morning we want to send a marketing email out to all our customers. How can we do that? And you don't want to scan through your entire table just to filter down to the customers. You're going to be doing a lot of reads of orders and inventories and all that stuff, which is going to vastly outnumber the customers. You don't want to be doing that. That's an inefficient read. So you say, how can we do this with a sparse index? That's what we'll do here. We'll add this additional attribute onto our customer items. So we add this attribute customer index ID, and we only give it to our customer items, right? Only those customers have it. The orders don't have it. Inventory don't have it. Then we'll declare a secondary index using that customer index ID value. If you see this is our secondary index. It's been filtered down to just those customer items. It doesn't have orders. It doesn't have inventory in there. So that's that second strategy, right? When we're using single table design with multiple entities in there, sometimes you want to get just a single type of entity. So you can use this second strategy to project a single type of entity into that secondary index really nicely, really efficiently. That's the third strategy, sparse index. The last strategy I want to talk about isn't really a DynamoDB strategy at all, but I think it's worth thinking about in your application. That's what I call client-side filtering. And Rick Houlihan's a big advocate of this as well. And the point here is make sure you're taking a holistic view of your application and the problem you're trying to solve. And sometimes it doesn't make sense to shoehorn every single filtering thing into DynamoDB itself. So what am I talking about with client-side filtering? This is when you're filtering, in the backend server or maybe on the browser front end. You want to do some filtering there, and rather than doing it in your DynamoDB table. This is good when 2 things are true. Number 1, filtering is difficult to model in the database, and there are certain filtering problems in DynamoDB that can be difficult to model there. Particularly if you're filtering on multiple different values and all of them can be optional, it can be pretty hard to model that in DynamoDB. So that can be difficult. And then also, if the data set just isn't that big, it might be better to use client-side filtering. And when I say the data set isn't that big, I don't mean your table as a whole. I'm not talking about all those items, but I'm talking the particular view you're wanting to filter on. So if you can narrow down your database to a particular portion of that filtering, you might be able to use this client-side filtering. So let's look at this with an example. Again, let's go back to that actors and actresses and movie roles table we have here. And let's say, when we look at Tom Hanks's page, when someone goes to Tom Hanks's page, they want to be able to filter out and say, hey, give me everything before the year 2000. Or maybe they want to filter and say, hey, give me only drama movies that Tom Hanks has been in. Well, we could try to model that in DynamoDB, but really, if you think about it, Tom Hanks doesn't have that many movies, right? He might have 60 items in our table, maybe 100 if you're a very popular actor that's been in a ton of stuff. But really, there's not that much data there. So what we could do is when someone goes to Tom Hanks's page, just fetch all of Tom Hanks's data, return it to the client, on the browser, and then do your filtering in the browser, because there's really just not that much data to worry about to where you need to get specific with your filtering patterns. So the big key here is make sure you're thinking about your problem as a whole, and don't try and jam all these problems into Dynamo when it's pretty easy to solve outside of Dynamo as well. So that's client-side filtering with DynamoDB. Again, those are the 4 filtering strategies you want to do. Those first 2, filtering with the partition key, filtering with the sort key, that's all your primary key-based stuff, and that's going to do a lot of the filtering work for you. But make sure you know about sparse indexes, client-side filtering as well. All right, let's move into the last section. We're going to talk about sorting strategies here. So additional strategies specifically related to sorting. And I want to start off with the basics of sorting, right? What does sorting mean in DynamoDB? So first thing you need to know is that only the sort key is sorted, and it's sorted within a particular partition key. So let's go back to that SAS example that we already have, right? Where we have these 2 different organizations. We have 2 different item collections there. You can see I've outlined in red and in blue 2 different item collections and the sort key values there. And within that red box, all those items are sorted according to that sort key. Same with the blue box, but they're not sorted across partitions. So you're not going to get sorting across your table, just within a particular partition key. Now, that sorting is done in order of UTF-8 bytes, which basically means alphabetical, but there are a few caveats here that I want to walk through. So let's look at this quick little example. Maybe I have a few people stored in my table. I have myself, Alex Bree, we have Jimmy Dean, we have Laura Dern. One thing you might notice there is wait a second, why is debris, DEB, listed ahead of Dean, DEA, right? B comes after A in the alphabet, so shouldn't that become after it? And the thing you need to know about UTF-8 bytes is all uppercase letters come before all lowercase letters. So in this case, both the D and the E are the same, and then that uppercase B comes before the lowercase a. So that's why debris is ahead of Dean there. If that's going to be a problem for you, you might have some different casing across that. Make sure you standardize that, right? Make sure you capitalize all these letters or lowercase all those letters so that you have consistent sorting across these regardless of that casing. So again, order in order of UTF-8 bytes. 3 things you need to know there. Alphabetical generally, but uppercase comes before lowercase. And then you also need to think about where numbers and symbols fit in. Easiest thing I can say to you here is just Google UTF-8 byte chart. You'll get a chart and it'll show the ordering of all this stuff, where the symbols, where the numbers fit in, and you can use that accordingly. One question I get asked a lot is, how do I do sorting with timestamps in DynamoDB? Specifically, should I use an epoch timestamp or should I use ISO 8601? So the great thing is either one will work. Epoch timestamp will work. ISO 8601 will work. They're both sortable. The nice thing about ISO 8601 is that it's human readable. So if you have to go to the DynamoDB console or print out a DynamoDB item, it's human readable. It's very easy to see what's going on there rather than converting back and forth to an epoch timestamp. So that's what I like. So I tend to use the ISO 8601 timestamp. You can see here, I've got an IoT application where that timestamp is the ISO 8601 format, and it's already in UTF-8 order where it goes, chronologically there. So that's great. So if you're going to use a string-based time format, make sure you're using something like ISO 8601. Don't use something that's like, month, day, year, because then it'll get all out of order there. Also, don't get anything that sort of like writes out the month, right? Don't say May 26, 1988, anything like that. Make sure you're using something that's designed to be sortable chronologically. So that's sorting with timestamps. Last thing I see in the basics of sorting, I often see people have a need for unique sortable IDs, right? So when you're creating new items, you need a unique identifier. People often reach for UUIDs, and they're great. But the problem with UUIDs is they're not sortable in any way. So it'd be great if you can have an ID that's both unique but also sortable by creation date. And there are a couple different implementations of this out there. So you can use either a ULID or a KSUID. Let's just look through each of those quickly, right? So ULID is an open spec. You can find it on GitHub. Basically, what you're going to get is a 128-bit string. The first 48 bits is going to be a millisecond timestamp, and the last 80 bits is going to be randomness. They're URL safe, so you can put them in a URL, use them to reference to items. Really works well. And then they're lexicographically sortable, that's really what you want. You want to be, creating these items. Maybe it's order IDs or something like that, and it's going to be sorted chronologically, so you can get that sorting right out of the box there. You can also use the KSUID. This was made by the folks at Segment. Pretty indistinguishable between these two. You can pick your poison there. So let's just see a quick example of what I'm talking about here. Imagine we have an e-commerce application where one customer makes orders. When they make orders, we want to give them a unique ID for that order, but we also want to be able to show them orders in terms of their creation date, right? So you can see here, if we look at those attributes on the right, they're sorted in ascending order, but we're not using that created at timestamp in the sort key. Instead, what we're using is that ULID, and that's what it's going to look like there. It's just going to be a string that's going to be sortable chronologically, but really work nicely in a URL. All right, so that's the basics of sorting. 2 other topics I want to talk about with sorting that often catch people up. And the first one is about sorting on changing attributes. So often you have some sort of use case where you want to sort on something, but that attribute is going to be changing. And how do you handle that? And the example here might be a game leaderboard, right? You might have a particular game that's your partition key, and then different users have scores within it, and those scores are changing, and you want to sort by that to show who's in the lead, things like that. You could also have orders, as we'll see in a sec. Maybe you want to sort by updated at rather than created at. So the difficulty about this is if you build that changing attribute into your sort key, it can be difficult to update that attribute because changing a primary key requires 2 actions, a delete and a put. Because if you're changing the primary key of an item, it's like you're making a new item, right? Because the primary key uniquely identifies that item. So you can't just update that primary key. It's actually a new item that you're creating. So it's sort of a hassle to change attributes in your primary key. So what I'd recommend is to use a secondary index if possible to handle that, and then DynamoDB is going to handle that for you. So let's just take a look at an example here. We're going back to that e-commerce example I just showed with orders. And let's add an updated at timestamp here. We've got that on the far right in the attributes. And imagine we say, hey, instead of showing users their order in terms of created at date, we're going to do it in terms of updated at date. So you might think to jam that into your sort key like this, and now your timestamp is in that sort key. But again, every time you need to update that item to change it from, ordered to shipped to delivered, things like that, you actually need to delete the whole item and make a brand new item, which you don't want to do there. So we're going to handle a different strategy like this. Let's go back to what we had. Instead, we're going to add this GSI1 PK, GSI1 SK. And the values we're doing here, we're taking that updated at value and putting it into our SK. And now every time we update our item, we'll update that updated at value. We'll also update that GSI1 SK. And now DynamoDB is going to handle that delete and put in my secondary index. I don't need to think about it at all. You go look at my secondary index, and it's sorted in order of updated at date. Very easy for me to query that index and say, hey, get me the most recent 10 updated items for this particular user. So that's the big takeaway there. If you have an attribute that's changing that you want sorting on, do it in a secondary index rather than in your main table. Last thing I want to talk about was sorting, and this is ascending versus descending. This can trip some people up as well. But basically, when you're running a query operation in DynamoDB, you're going to be giving it a partition key and getting some range of sort key values back. And it matters whether you're starting at the beginning of your match and sort of moving downward in your item collection, or starting at the end of your match and moving upward in your item collection. If you want to change the direction of that, you can do that using a scan index forward property in that query operation. That can be true or false. We're going to see how you'd want to use that in just a second here. The important thing to know is when you're modeling, this is really important if you're combining multiple entity types in a single item collection, right? So if you're doing some of that pre-joining of your data, you might need to use this scan index forward property to sort of join them correctly. So let's look at an IoT example here. Again, we have a device item is our partition key, and we have two different entity types in our item collection. So at the very top of our item collection, we have our device item, and then we have many reading items. So there's a one-to-many relationship. We've already pre-joined in this item collection with the device item at the top and the reading items at the bottom. Now, the most common access pattern here is probably going to be get the most recent readings for this device. And so we go to this, we say, hey, start scanning this item collection. If you look at this, we do this get readings. If it starts at the top of that item collection, it's going to get the device item, but then it's going to get the oldest readings first, right? And we don't want to fetch the oldest readings. People don't care about readings from 2 years ago. They want to get the most recent readings. So we're going to scratch this design. We're going to change it up a little bit. Instead, what we're going to do, we're going to locate that device item at the bottom of our item collection. So what we've done here, we've changed it up. We've added this little hash prefix to all of our reading items so that they go above our device item in our item collection there. Now, when we do a query, we're going to do scan index forward equals false. It's going to start at the bottom of our item collection, scoop up that device item, scoop up the most recent readings for us, and return those for us so that we get the freshest data there. So make sure when you're doing this, you use that scan index forward property, true or false, to get the most recent items or to read that accordingly. So those are the big sorting strategies there. Make sure we talked about the basics of sorting, how it's sorted, thinking about UTF-8 bytes and those unique identifiers as well. Then we talked about some specific problems, sorting on changing attributes, ascending versus descending. That closes up this talk. Just a reminder of what we talked about. First, we started off with that data modeling process. How do you approach a problem in DynamoDB? What are the steps you walk through? Then we looked at two different types of strategies, right? We did filtering strategies and said, how do we efficiently get the data that I want to get? And then we talked about sorting strategies to say, how do I use that sort key efficiently in my data model? Just a reminder of what we covered in part one. In case you were lost in this one, go back and watch that one. But we talked about DynamoDB basics. It's got some vocabulary, terminology there just to get you on the right page. And then we talked about SQL versus NoSQL, just to give you the right mental model of the problems that NoSQL is trying to solve and how you need to model your data accordingly. And then finally looked at one-to-many relationships just to see how that works in practice. So make sure, if you missed it, go back and watch that data modeling with DynamoDB part one. And again, go check out Rick Houlihan's sessions as well. He does a great job every year. Again, most watch on YouTube, most watch at reInvent. Everyone loves them. Advanced Design Patterns with DynamoDB part 1 and 2. I love his sessions every year. And thank you for watching. I'm Alex Debris.